Questions on the homework? We still have a little bit of time. No, I will do some graphing just to kind of show us kind of the inverse, because what we're looking at today is inverses. But it's not something you'll need. So, all right, guys, let's focus in. You can put them on my desk. Thank you. Now, what we're doing today is inverses. This is the last section. This is the last thing we're covering this year. Now, an inverse is a function. A function has an inverse if and only if it passes the horizontal line test. So if the function itself passes the horizontal line test, we can draw a horizontal line and it only crosses or intersects the function at one point, then its function then its inverse is a function. Because when we look at the inverse, we're switching the x and y. So we're switching the domain and range. We're flipping it. So if, like this one here, the second one, it does not pass the horizontal line test, it crosses at two places, it still has an inverse. But its inverse is not a function. Because if we switch the x and y, the domain and range for this here, its inverse is going to look something like this here. And if we look at that inverse, determining if it is a function, functionality or determining if an equation or graph is a function is the vertical line test, yes? Well, the one I just drew does not pass the vertical line test. It crosses in two places. So that's the way we can tell if a function's inverse is a function. You can still have an inverse, it's just inverse is not a function. Does that make sense? Because we can have equations for shapes, or we can actually have an equation that's not a function. Equation of a circle, x squared plus y squared is equal to the radius squared. We do have an equation for it, but a circle is not a function. It does not pass the vertical line test. It's still an equation. We have it. It exists, but it's not a function. So an inverse, all of them can have an inverse. It may or may not be a function. There's still an equation for it, but it just may not be a function. So we can still find the inverse of this quadratic. It's just it might not be a function. It still has an equation. The equation is just not a function by definition. So, and there's things we can do, and we'll get into that. But the biggest thing is just finding inverses, and that's what we're really going to be looking at. And yes, we're skipping over example 1 because example 1's pretty much what we're doing. It's just they have it in a different context. Now we do have steps, I think. So our first step in finding the inverse is 1, rewrite f of x as y. It could be f of x, g of x, h of x, q of x. We're just rewriting it as y. We don't always have to do this, because it could be that they already give us the equation y equals form. If it's already in y equals form, we don't have to worry about step 1. We good with step number 1. Step number 2, switch x and y. Switch x and y. Everything else about the function stays the same. But we'll still have the 3 and minus 1. But our y is now x, and the x is now y. Because a function and its inverse, the domain and range switch, our input, the x, and the output y, flip. So we switch x and y. And for this here, what we'll do with these inverses, we won't have a whole lot to it, but if there was, say, 2 x's, it was 3x squared plus x. Well, now it's 3y squared plus y. Every x becomes y, every y becomes x. Normally, especially with y becoming x, is normally just 1. x's we can have more than one, but here we're not going to see that too much. Are you ready for step number 3? Solve for y. All that means is get y by itself. We flipped it, now we're getting y by itself. So the first thing we can do to get y by itself is to add 1 to both sides, which will tell us that x plus 1 is equal to 3y. Because when we're trying to solve for y, get y by itself, addition, subtraction as far as we can go. Then multiplication and division, powers, exponents are kind of last. Because again, addition, subtraction is one of the easier things to move. Multiplication, division is a little bit bigger. And powers and radicals, if we have no other option, we do those. Now at this point, the only other thing left with y is our 3, and we divide it, telling us that y is equal to x plus 1 over 3. And our last step is to rewrite y as f inverse of x. Now, it won't always be f inverse of x. And the times that it will not be f inverse of x is if we didn't start with f of x. So if our original function was g of x, our final statement would not be rewrite y as f inverse of x. It would be rewrite y as g inverse of x. So if we start with f, our last one's going to be f inverse. If we start with g, the final one's going to be g inverse. I mean h inverse. They go together. Then you just give me y equals. And the reason that they have f and this here f to the negative 1 inverse is to distinguish which one's the function, which one's the inverse. Questions on this here? Now, one of the nice, interesting things with this here is our original function was 3x plus, was it? No, minus 1 was our starting function. Our inverse was x plus 1 over 3. Now, the one in red, as we can see here, is the inverse. Our blue one is the original function. And we do have that third pink line thrown in the middle, yes? Two equations are inverses if they're reflected across the line y equals x, the one in pink. And we can see here they are a mirror image across that line. So they are indeed inverses. All inverses will reflect across this line. But we don't have to do that. We don't have to show it. There are other ways to show it, but that's our inverse. That's it. Questions on this here? Let's look at the next one. Find the inverse of f of x equals 2x plus 8. First step, replace f of x as y. What's our next step? Switch y and x, switch x and y. So we have x is equal to 2, yes. 2y plus 8. And then, yes, our third step is to solve for y. And the first thing we can do is minus 8. Giving us x minus 8 is equal to 2y. And then divide both sides by 2, telling us y is equal to x minus 8 over 2. And our last step is f inverse of x is equal to x minus 8 over 2. Questions on this here? We good with this so far? We're ready for the next one. F of x equals 2x. So we would say y equals. Yes, then we would switch x and y. Yes. Switch x and y. Divide by 2. Y is equal to x over 2. Our F inverse of x is x over 2. Questions on these here? We ready for the next one? I have a feeling for the most part we feel comfortable with these here, yes? This one here, we can go on and do it because we would rewrite f of x as y. Then we would switch x and y. Next step would be 2 minus 1. Knowing this x minus 1 is equal to negative y, yes? Yes, we can divide by negative 1 or multiply by negative 1. Both work. Now, here, negative y divided by negative 1 is y. Now, we don't leave x minus 1 over negative 1. That's just an odd way to write a number. But that negative is being applied to both terms. Because what we could have said, instead of dividing, I could multiply by negative 1. Same thing. Negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. So f inverse of x is negative x plus 1. Now I will show you the other way, because if we said x minus 1 over negative 1, yes? That's the same as x over negative 1 minus 1 over negative 1, or we can say plus negative 1 over negative 1. Same thing. Because our x over negative 1 is just negative x. Negative 1 divided by negative 1 is 1. We get the same thing, we just have to reduce. Now, yes, a good question is why didn't we do that on the one before? This one here, everything reduced, yes? If we look at the previous one, does x over 2 reduce? No, it's not divisible, it doesn't simplify. If I look at the one before it, 8 over 2 does reduce, yes? Does x over 2 reduce? No, because I could write this as x over 2 minus 8 over 2, which would be x over 2 minus 4, but is that any simpler than just saying x minus 8 over 2? Well, no, so we just leave it. Does that make sense, the difference? Because we don't want to leave this as x minus 1 over negative 1. It's just odd. It's just not a great way to say it. Does that make sense? Are there questions on this here? Now, there's a lot of times with inverses where it's going to be easier to multiply than it is to divide. This here is a good case in point. Now, our steps are still the same. Rewrite f of x as y. Switch. X and y. Solve for y. Well, the first step is nice. We add 2 to both sides, telling us x plus 2 is equal to 1/3 y, or y over 3. Yes? Now, our instinctual answer is, say, we're going to divide both sides by 1/3, yes? The other way we could do it, instead of dividing by 1/3, we could multiply by what? 3. we can take that fraction and flip it. And we can multiply both sides by 3, or 3 over 1. We just flip it. And this is nice because a fraction and its reciprocal, its flip, when multiplied together, give us 1. We've had this before, we just didn't think about it that way, because perpendicular slopes are opposite reciprocals. So when we multiply perpendicular slopes, it gives us -1. That's because the signs are different. But again, when we multiply something by its reciprocal, we get 1. And that's nice because here, when we do this multiplication of 3, 1/3 times 3 over here simplifies to 1, leaving us with y. The other side, we distribute the 3. 3 times x is 3x plus 6. Now, if we were multiplying by, say, 2/3 or 3/2, the number on top would multiply through our expression. The number on the bottom of the fraction would now become the new denominator, the bottom of the fraction. Because this is a lot easier to work out than trying to do x plus 2 over 1/3. We cannot leave a fraction in a fraction. So to simplify this, we'd have to say that we have x plus 2 divided by 1/3. To multiply fractions, we change flip. Keep the first one the same, change it from division to multiplication and flip. And then multiply and get the exact same thing. So we might as well just multiply by its reciprocal, then try to divide and go from there. Does that make sense? Now, I specifically say that if the number we're trying to get with multiplication or division away from y is fractional, if it had just been 3, we can divide by 3. It's nice and easy. Does that make sense? Good questions on this here. We feel good with these so far. Yes? Okay. Now the next one here is we want to find the inverse of f of x equals x squared. X is greater than or equal to 0, then graph the function and its inverse. Now there's a reason they added that piece in. Because again, we said if a function or equation has an inverse, it has to pass the horizontal line test. That means the graph of f of x equals x squared, y equals x squared, if its inverse is a function, has to pass the horizontal line test. I'm just going to make it in a line at 5. Does it cross at 2 places? Yeah. So that means its inverse is not a function. But the second part, it said x is greater than or equal to 0, yes? That means for x squared, our blue graph, we are only looking at the x values that are greater than 0. So we're looking at just the right side of the graph. We've removed the left side. But by doing that, the horizontal line only crosses at 1. It's still going to show both because I haven't added the restrictions or gone through the process of doing that. But the left side of the graph is now gone. We just have the right, so its inverse is a function. We just took the one side out. Does that make sense? Okay. We ready for the steps for finding the inverse? If we can do it in a little bit. Thank you. So, now the steps for finding the inverse for this here with an x squared. Yes? We ready? First step, rewrite f of x as y. Rewrite f of x as y. Anybody have a guess at what step 2 is? Switch x and y. Solve it. Get y by itself, yes? And again, when we're getting y by itself, addition, subtraction, multiplication, we try to do all that first. Well, there's none of that. What do we have to do to get y by itself? Square root both sides. We take the square root of both sides. Now the square root of y squared is y. Square root of x is, and again, anytime we apply an even root to both sides, we have to add the plus or minus. Now, if it's already applied to it, you're just trying to find the fourth root of 16. It's just 2. We didn't apply it to it. That's the only distinction I can see. But here we're solving, so we add the plus or minus. Yes? Now, we keep the plus or minus there if there is no restriction to start with. Our restriction to start with said that x is greater than or equal to 0. Yes? So that means we're only looking at the positive side. Equals, I'm going to get rid of this, negative square root of x. Well, that's not quite the case because it means positive x. We switched the domain and range, yes? So the input for the original function was only positive. It's now the output. The output has to be positive, yes? So that means the negative case for this here does not work. Because its inverse would just be the positive side. Does that make sense? If it didn't have a restriction at all, we would have plus or minus, but here f inverse of x is equal to the square root of x. Positive square root of x because we wanted positive. If you leave it with the plus or minus, I will still take it. But that's how we get to that there. Questions on this here? Are you ready for the next one? Find the inverse of x squared minus 2. X is greater than or equal to 0. So again, we have the positive case with our plus or minus. So we have replace f of x with y, so y equals x squared minus 2. Switch x and y. Solve for y. As much as we would like to take the square root of both sides, I would not move that or do that first. I would add 2. Because that's going to tell us y squared is equal to x plus 2. What can we do next? Square root. Because we don't have any other addition, subtraction to take care of, multiplication, division, so now we're stuck with our exponents and roots. So now we would take the square root of both sides. Square root of y squared is y. Equals plus or minus the square root of x plus 2. But again, since we're looking at the positive case, because it told us x is greater than 0, it's going to be the positive. If they set the restriction as x is less than or equal to 0, we would have the minus, we'd have the negative, not the positive. But since it is the positive, we don't have to put a plus. We can just say the square root of x plus 2. Questions on this here? It is plus or minus, but because up here they said x is greater than 0, the negative case we don't have. Now, if it just told us to find the inverse and then add the x is greater than or equal to 0, yes, we would leave the plus or minus. Questions on this here? Okay. Now this does have an inverse. Again, graphically it can look like it doesn't because it makes more of an S shape as it comes. And the graph, if we did graph it, it probably looks something, not quite. And it's going to have this more at 1. It should be a little higher up. But we have an S-type curve. Now this is, its inverse does exist. 2x cubed plus 1, we're going to find its inverse. And the inverse steps still don't change. First thing we have to do after rewriting as y is to switch x and y. Now we need to get y by itself. So we would subtract 1 from both sides. Minus x minus 1 is equal to 2y cubed. Minus y cubed is equal to x minus 1 over 2. And lastly, we would cubed root of y cubed is y. The other side is going to be the cubed root of x minus 1 over 2. Now we're not trying to simplify it or rewrite it in any form. I will take that there, especially with finding inverses. I'm not going to make you rationalize that denominator. That's it. Now again, with odd roots, we don't need the plus or minus. We only need it with even roots. Questions on this here? So how do we feel about these here? We feel good with these. I'm going to skip this one if you want to do this. You should get the cubed root of x plus 2 over 3 if you went through and solved this here. And because if we looked at the function itself to get it by itself, we were going to need to add the 2, divide by 3, and then take the cubed root to get it. So it's just looking at it one part at a time. Yes. Mm-hmm. Because we still have enough time to get through this. I just want to make sure we get through this. And for the most part, I think we're getting this. Yes? Consider the function f of x equals 2 square root of x minus 3. Well, we rewrite f of x as y. Y equals 2 times the square root of x minus 3. Yes? Second step is to switch our x and y. X equals 2 square root of y minus 3. Yes. Now we need to get y by itself. And again, I always start with addition or subtraction, multiplication, division, powers, and square roots last. And there is the minus 3, but the minus 3 is trapped inside the square root. We have to get rid of it first. But the 2 outside, these would simplify, leaving us with the square root of y minus 3. The other side is x over 2. Well, now we've run out of things. Now we've got to deal with that radical. The only way to simplify a square root is by squaring it, putting both sides to the second power. Because the square root squared simplifies, leaving us with y minus 3. Now the left-hand side, we're not going to leave it as x over 2 squared. Properties of exponents, we can actually apply the power to the top and bottom. We're really saying x over 2 times x over 2. X times x is, and 2 times 2 is 4. We just squared it. If there had been like x plus 1 over 2, then we actually have to write out x plus 1 times x plus 1 and go through the multiplication process. There is no addition subtraction in that, so we don't have to worry about that there. Is y by itself. Now, so we would add 3 to both sides, telling us y is equal to x squared over 4 plus 3. And last but not least, we would yes, we could technically rewrite it as a single fraction if we wanted to. There's not a whole lot of reason to do that. And we would have, in order to do that, we would need to change 3 so it has a denominator of 4, which would really just tell us that it's x squared plus 12 over 4. I'm okay with either one. Questions on this here? Or would we say that was a lot harder than the ones we did prior? One step at a time. And we can get that there. We rewrite f of x as y. Then we switch x and y. Yes. Because our right side will be y plus 4. The left side would be x over 3. Now, if there'd been an addition or subtraction outside the radical, yes, we would add or subtract to get it over first, then divide. But we didn't have it, so we just had to divide. Then we would put both sides to the second power. Now on the right-hand side, the square root and square would cancel. Notice we have y plus 4. Left side, we don't have any addition or subtraction in the top or bottom, so we can just square both terms. X squared as well, x squared. 3 squared is 9, yes? Now, I sometimes do get this question, why don't we put the plus or minus on this here? Because we're saying the square root is equal to x over 3, yes? Only numbers that can come out of a square root are positive. We can never have a negative come out of a radical, so we don't even need the plus or minus. But the numbers that come out of a number being squared, the number inside could be positive, it could be negative. We have both. Here, not even an option, so we don't put it. And lastly, we minus 4. Minus y is equal to x squared over 9 minus 4. X squared over 9 minus 4. And on most of these here, we would probably restrict the domain, but I'm not too concerned about that. Because our starting function was 3. Second square root of x plus 4, yes? Make sure I'm 3 square root of x plus 4. Okay. Graph. We have this here, yes? Now, the inverse that we found equals squared over 9 minus 4. Graph. We can see there's a little more to that equation than just what we have there. So we would technically need to apply a restriction so it does stop at negative 4 and doesn't go past that, but I'm not too concerned with that. I'm more concerned with you being able to find the function. Does that make sense? Okay. We're ready for the last piece. Verify that f of x equals 3x minus 1 and g of x equals x plus 1 over 3 are inverses. We want to know if they are indeed inverses. Yes, and that is one way that we can do this. Now, what's interesting is that we can plug it in. Because for this here, for a function, we're taking the x value and putting it to the y, yes? So if we call this the domain range, so f of x would take a point from here to here. Its inverse is taking those range values back to the domain, yes? And if two functions are inverses, f of f inverse of x, or we'll call it f and g, if these are indeed inverses, f of g of x will equal g of f of x to both give us x. Because if f of x takes 4 to 7, its inverse should take 7 back to 4, yes? And the composition function, so if I plugged 4 into g of x and got 7, and then I plugged 7 into f of x and got back to 4, they are indeed inverses. One takes us back to the other. So for this here, we're going to take the composite function. So f of g of x. That's why we did those yesterday to test these here today. Now sometimes, like Brianna was saying, it's easier to just find the inverse of one of them and match it up to the other. Here, f of g of x. Well, g of x is x plus 1 over 3. Now you do have some of these on the homework. If one of them does not come out as x, we are done, because they both have to equal x. Now when we plug this in to f of x, every x in f of x, this one here, becomes x plus 1 over 3. So we have 3 times x plus 1 over 3 minus 1. Okay? Now again, some of these, I do have one of these on the bonus for the test. There is a lot to it, but take it step by step. Because if we take it one piece at a time and just slowly take it apart, a lot of this starts unraveling pretty quickly. Like that one, that one small thread on a shirt, you start pulling it and everything starts coming apart. Because if we look at this here, there is a decent bit, but this 3 and this 3 will cancel because we're doing 3 times 1/3. 3 over 3 simplifies, leaving us with x plus 1 minus, our 1 minus 1 is 0, leaving us with x. So f of g of x is x. If we get anything, I mean anything other than just x, it could be 6x, it could be 7x. They're not inverses, and we're done. Both have to equal just x. Does that make sense? Let's look at the other side. G of f of x. Well, f of x is 3x minus 1. Now we're going to plug that into g of x. Which would be 3x minus 1 plus 1 over 3. I'm going to write it without the parentheses. So on top, we have 3x minus 1 plus 1 over 3. Our negative 1 plus 1 become 0, so we just have 3x over 3. 3x divided by 3 is? What are these inverses? Yes. Because f of g of x is equal to g of f of x, and they both equaled x. That is literally, yeah. Questions on this here? Because we do have more of these here, and no matter how complicated they get, we still take it part by part. Yes. Because this one here doesn't work. I'm going to put these homework sheets right here. So I'd grab one on the way out. But here, if we plug this in, the cube root and cube would cancel, telling us we have 8 times 2x, which is 16x. I know I'm doing that pretty quickly, but it doesn't matter what g of f of x is. If one of these is not x, it's not going to work. It's not going to work at all, because the other side ends up being 2x cubed root of 2. So they're not even the same. So since they're not inverse, these are not inverses. Yep, not inverses. And I will say there are a few, the inverse is the same thing as the function to start with.